Hello everybody and welcome back. We're still looking at the 2002 Pascal competition. That is the grade 9 math level competition put out by the University of Waterloo. And hopefully you've joined me for some of the questions, although if you're just joining, you can grab a copy of the contest by clicking the link in the description. We're taking a look at question 23. If you're interested in any of the other questions, you can take a look on my channel. All the previous ones are up there so far. So question 23, the number of ordered pairs, A, B, so order does matter, there might be some duplicates here. Ordered pairs, A, B, of integers is italicized here, which satisfy the equation A to the power of B equals 64 is, okay. So we have some options here, 3, 5, 8, 6, 7. All right. So this is a sort of question that I'm not the biggest fan of. There's not really a good way to go about enumerating this list. I'll try my best, but it's not like listing out the factors of a given number where you do a prime decomposition or something like that. No, we don't quite have anything like that. We're a tad stuck here. But I'll try my best. So A to the B is equal to 64. Well, the first thing I notice here is 64 is 2 to the power of 6. That's really nice. There's a couple things you should always sort of know when you're going to do these contests. One of them is, I think most people should know, the first 20 perfect squares. First 25 is even better, but first 20 perfect squares certainly are a very good thing to know. There's 64 right there. Oops, I got the order wrong on those two. Just because you don't want to have to go to your calculator every single time. These numbers come up a fair bit. So it's a good idea to be aware of them. So first 20 perfect squares, that's always a good idea. First 10 cubes, I think, is also an excellent thing to be aware of. Now there's 64 again. 216, 343, the 7 squared, 8 squared, and 9 squared are ones that people particularly don't seem to remember quite well. And another thing, you can do fourth powers if you want. I think perfect squares, perfect cubes are probably the best for contests, but fourth powers do come up. And then another thing that comes up a whole lot are powers of 2. So 1, 2, 4, 8, 16. These are also good to know if you're ever going to go on, or maybe you already have, and done, there's 64 again, computer programming. But there's lots of powers of 2 below, 1,000. So there's knowing maybe all of them up to 512 or beyond. Maybe up to 1,024 is pretty good. But it's nice to be able to recognize powers of 2 when they hit you. Eight, 1, 9, 2, and that's about it. That's as much as I really know. Once we get into the 5 digits, I don't find that they're as common. So these are numbers that I really recommend people know, work with them, have them memorized, be able to say 13 squared, that's 169, or 7 cubed, that's 343. These are just numbers that pop up a whole lot. Other things to know are Pythagorean triples. The first few of those are really good, and some of their multiples like 6, 8, 10, and 12, 16, 20. But enough about that. Let's get back to the question. I notice immediately that 64 happens to be 2 to the 6. It's a power of 2. It also apparently pops up in these other lists as well. But I can tell you immediately 64 is 2 to the power of 6. Okay? Now, just from these lists, we also have that it's 8 squared and it's 4 to the power of 3. So already we have 3 answers, 3 ordered pairs here. So we're looking at A, but A was sort of a given. It's got to be at least 3. But when I look at, specifically, I want to look at 2 to the 6, and the reason being, I can't sort of simplify that anymore. If I look at 8 squared, well, 8 is already a power of something. And 3 times 2 is 6, so we get a 6 here. Same with 4. 4 is already a power of something. So we keep recovering this 2 to the 6, but 2 isn't a power of something. We have a prime decomposition here. We have a prime factorization. 2 to the power of 6. That's as good as we're going to get. And so this is the one that really sticks out in my mind. And this is the one where I'm going to start my list off. So if 64 is written as a to the b, and that's 2 to the 6, well, I can tell you, since a and b are integers, and that tells me that 2 divides a times a, b many times. And that's the definition of what a to the b is. Okay? Now, 2 is a prime number. And primes have a very nice property. If I have a prime number, and I know that p divides, let's say, x times y, then that means that p divides x or p divides y. Right? This isn't true if you're not a prime number. For example, 12 divides 4 times 6. 4 times 6 is 24. 12 divides that. But 12 doesn't divide 4, and 12 doesn't divide 6. So neither of those are satisfied. So the fact that p is prime, that tells me that 2 is prime. That tells me that when I write out this nice product here, that tells me 2 has to divide a. Okay? 2 has to divide a, and that's pretty special. Because that tells me that a is likely some power of 2. So let's write a as 2 to the power of c, for some power. Then 64 is 2 to the power of c to the b. That means it's 2 to the b times c. Right? When we raise a power to another power, we can multiply the exponents. But 64 is 2 to the 6. So 6 is the same as b times c. And that tells me b is a factor of 6. All right. So, well, there's only so many factors of 6. B could be 1, it could be 2, it could be 3, or it could be 6. So what if b is 1? If b is 1, then c is 4. Sorry, not 4, 6. Doi. So a is 2 to the c, so that's going to be 64. So we're looking at the pair 64 to the 1. If b is 2, then c's got to be 3. We're looking at a is 2 to the 3. It's going to be 8. So we've got 8 squared, 8 to the 2. Okay? Now, if b is equal to 3, c's got to be 2. 2 to the c, so that's 2 squared. So a is going to be 4. And we're looking at the pair 4, 3. 64 is indeed 4 cubed. Finally, if b is 6, c's got to be 1. So a is going to be 2, and we're looking at 2 to the 6, or the pair 2, 6. So we said here 2 divides a, so let's just write a as a power of 2. But that might have been a bit hasty, and indeed it was. But all we know is that a is a multiple of 2. So yeah, we've got some nice examples here. We've got, what was it? 1, 2, 3, 4 possibilities. But if I were to just go with that and say, well, let's bubble in 4, 4 isn't one of our possible answers. So we know there's something else out there. So all we knew was that 2 divides A. Now let's suppose A is 2K, where K is just some other integer. Well, then 64 is equal to 2 to the K to the power B. So that's 2 to the B, K to the B. But 64 only has factors that are powers of 2, right? Other than, say, 1s. So, how do we want to say this? Let's let P be a prime and P divide K. So let's suppose that K has a prime dividing it named P. Well, then P is also going to divide K to the power B, because B is certainly not 0. And so P divides 64, but that's got to be 2 to the 6. So P must be equal to 2. K can only have factors of 2. Now you might be saying, well, you've just gone in a circle. If K's got to be only have factors of 2, K must be a power of 2. So you're really looking at A is 2 times K, 2 times the power of 2. A is going to be a power of 2, right? But we made an assumption here. We said let P be a prime where P divides K, and that is not always true. Can you think of a number that doesn't have any prime factors? An integer, specifically. An integer that doesn't have any prime factors. 1 or negative 1. Okay? So yeah, K is a power of 2 in this case. And we already covered this, because that would lead to A being a power of 2. But we made the assumption that P exists, where P is a prime that divides K. If K is 1 or negative 1, no such P exists. Alright? So no such P exists. So let's take a look at that. What if K was 1? Well, could we have had, so we'd have 2 times 1 to the power of B is 64, but that's 2 to the B, 1 to the B is equal to 64. Well, that would all be fine. There wouldn't really be any problems with that. The 1's not really going to contribute anything, but if I take a look at minus 1, suddenly I remember, oh yeah, I could have negative 2 to the power of 6, and that's also 64. And come to think of it, I can have negative 8 to the power of 2 is 64 as well. So let's go back and take a look at all the other powers that we worked out. Can we have negative 64 to the 1 be 64? No. But we did have negative 8 squared, and that was also 64. Can we have negative 4 anywhere in here? No, negative 4 cubed is going to be negative 64, not 64. And we already said negative 2 to the 6 is 64 as well. So actually, I want to flip the page. That's what I want to do. So these are actually going to be the only two other possibilities. We dealt with k equals 1, we did all those, but with a minus 1, we can have a negative integer. We're told a and b are integers. They don't have to be positive. A's got to be positive. Or sorry, b will have to be positive, but a could be positive or negative. We get negative 2, 6 here. We get negative 8, 2 here. And that's it. We've exhausted everything. So only going to be 6 ordered pairs. And that's 64, 1. Anytime we had an odd one, we couldn't flip a minus sign. But anytime we have an even one, you bet we can get a minus sign in there. Two, 6, and negative 2, 6, the ones we just worked out there. So 6 ordered pairs. And we take a look here, that's D. Now when you do this question, if you don't do it as methodically as this, what's going to happen is you're going to say, okay, well, I get 6, but there's 7 and there's 8. Are there ones that I'm missing? Is there something else going on here? And that's why I don't particularly like this question. You have to be either psychotically rigorous, which is a tad odd for a 9th grader, or you basically have to just exhaust yourself and say, well, I can't think of any more. And I don't think, and this is just my philosophy, I don't think a math contest question should come down to, I just can't think of any more. I just can't think of any more. So that's why I tried to present you a slightly more involved or rigorous or heavy on the reasoning style solution to this one. But, you know, in the heat of the moment, you're not going to want to write all this out for yourself. You are likely going to just exhaust your mental list of, you know, powers of 2, squares, cubes, fourth powers. Which ones does 64 appear on the list? And did I take into account the minus numbers and everything like that? And I don't like that style of question. They pop up from time to time. So, and I'm sure there's questions out there that you don't like that particular style of question. I can't think of any off the top of the head that people have really told me, oh, gee, I hate this question. And I don't hate this question. I don't think it's the best question design. But there's always questions out there that we don't really like. Recording these, there's questions I just don't want to do, so I put them off for a day or so. And it's something that you have to be aware of. And if you don't like them because you're bad at them, then my best advice to you would be embrace the questions that you find hard. Embrace the ones that you have a problem with. Embrace the ones that are challenging, that you feel uncomfortable when you see them. Because if you do them and you run towards it and you break through your fear and you practice them, even if they still terrify you or if you still hate them at the end, you're at least going to be able to do them. And I would say that is at least some comfort when it comes to a math contest, that, oh, gee, it's got one of those questions on it, but at least I practiced, at least I know how to do it. So I can get through it and I can get to the fun questions. And there are always fun questions. 25 questions on these contests, there's always going to be a really great one, and you just gotta go out and find it. So that was question number 23, answer of 6. And we're going to take a look at question number 24 in the next video. Thank you guys for watching, as always, and I'll see you then.